Hello everyone. Today is the 10th video of my database management systems practical video series. Today I'm going to do the second video of the third day of database management systems, and it's also going to be the 10th video of the question list. Let's go to the question list and see what is our question today. Here's the question 10. And you can see here's the question. I'm going to read it first and then let's answer for this one. Kabithigolava Central College was the only active school in the area during the war season. There were only 15 students in the school. Also, there were only 5 teachers, and one of them was the principal of the school. Okay, the principal decided to add all students' details in a student's attendance marking system, so he would be able to mark the attendance after the main morning assembly at once. Think you are a reputed database engineer and the principal requested to make a database while another developer is developing the system. The details have been given below. Okay, here are the details below the context. Okay, I read the context, and let's see what we have to do in this question in order to complete this one. Create a database named Kabithigolava School and insert this data to tables graphically. Okay, we have to create this. There are 4 tables. We have to create this 4 tables and then insert this data into that tables. But before everything, I like to highlight some special feature in these tables. You can see here's the main table, student table. This table will this is the table which going to store all the details of the students. You can see there are 6 attributes in this table, and here you can see grade, village and transportation method. These attributes should store some words, no? For an example, the transportation method. You can see the attribute in this attribute. Only the numbers are stored in the records, and here you can see there's a table which called transport, and this is also stored the transportation method, and here you can see the word by bus, foot and motorcycle, bicycle, like that. Here you can see another attribute. It defines a ID for a record. You can see the ID is unique, and in the main table, in the transportation attribute, the ID is shown in the record. This is a method we use to shrink down our storage and make our database more efficient. That's because I like to explain this one. If you can imagine, we enter the transportation method. We don't create if we don't create this transportation method table, and we store these words inside this transportation method. They can be students. We can get let's think we can think there are 5 students in this table, in this school, who's using the same transportation method. For an example, 5 of the students in this school are using the bus as the transportation method to arrive to the school. If we enter those details or records into our table, the transportation method attribute will store the word called bus. That's a 3-letter word called bus repeatedly when we defining the transportation method. That way you can see we wasted a big storage in our database to store the transportation method. So but in this way we separate the transportation method, the words, into the separate table, and then we gave them IDs, the bus has the ID 1, and the food, the person who's using the transportation, or who's coming by foot to the school, are going to call number 2. When we store that numbers, only the numbers inside our main table, that will only cost us a 1 character. That means it will store the storage. That's the meaning. But when we all every time we are separating tables, these two tables, or like the transportation method and the student table, have some kind of a connection in order to define the transportation method. That means we have to use relationships, we done that in the previous videos, but let's see what we have to do in this one. But when we are defining these kind of tables, like more tables or separate tables, we have to define the connection, or relationship between these relations or tables. Now let's go to the, so that's what I have to tell you. Let's go to the our software. Today I'm going to use the workbench, because we have to create an ER diagram. ER diagram is the method we are using to define the relationship between tables, and we have to create a ER diagram, and then create the database from using that ER diagram. The only software that allows creating ER diagrams or modeling is the Workbench, the official software which came along with the MySQL server. So I'm going to open that one. Here's the Workbench software. You can see the connection to our database. I click on that. Here we are in the database, and then I'm going to create a new model. In this software, the diagrams are called models. So click on the File tab, and then New Model. You can see it opened a new database. Here we can create a change the database name. We are going to creating the database, and when we create the diagram, it's going to put inside this table. It belongs to the this database we are creating. Okay, I'm going to change the name of the database. Here I right click on the table, and let me do that again. Right click on the name of the database, and then edit schema. In this software, the databases are also called schemas, and I'm going to change this name to Graphically School. When we are defining, or when we are naming the database, we don't separate the words with spaces. We are defining or writing the name as a single word by connecting the two words using these kind of underscores. Okay, here I rename the database, and then you can see we don't have to save or do something like that. The software will automatically save our the changes we are doing to that database. And let's create the diagram. I'm going to double click on the add diagram button. Here you can see the workspace. Let me close these sidebars. Okay, here's the workspace. We are going to create our ER diagram. The people who watch my previous video, videos, they know what I'm going to do in this workspace. What we are doing in these workspaces, we can create tables by using this button. Here you can see add new table button, and then we can edit it by click on the edit table button. Okay, here's the window we used to edit our table we created. Here I'm going to rename the table. Let's go to the question and see what is the name. Here I'm going to create the main table, student table, and here are the attributes: number, name, birthday, grade, village, and transportation method. When we are creating this table, like in the past questions, they don't give us instructions to create or define data types or character length. So we have to define those details by ourselves. I'm going to do that here too. And let's create these three attributes first: number, name, and birthday. Okay, here's the table name, student. Okay, here's the attribute, first attribute, it will be number, and the data type is okay. It will store int values. Like in the table you can see only the integer values are stored in this attribute, so int is okay. And then I'm going to assign this attribute as the primary key, and also I'm going to auto increment this one. That's because you can see in the question every record is auto incremented by the past record. So I'm going to assign auto increment. You don't have to assign these values separately. You can just click on the auto increment button. It will automatically check the primary key and the not null checkbox, because only the primary key of the table will be auto incremented. We cannot use auto increment in other attributes after we assign a primary key, or after we assign auto increment once. Okay, we created our first attribute and the primary key. Let's create other attributes which are names and birthday. Okay, here's the second one, name, and I'm changing the value. The name is going to store string values, so Bacha is okay here. And here's the place we are defining the character length, which is defining how much characters will store in a single cell. So I'm changing the value to 25, or I'll change it to 40. The 45 is too much, so I'm changing it to 40, and I'm going to click on the I'm going to check the not null checkbox, so that will not store null values automatically when there's no value recorded by the user. So let's create the third one, birthday. Here's the attribute birthday. In the birthday attribute, we are only going to store date. So in MySQL, there's an option or there's a data type to store date specifically. Here's the data type date that will store the date in this format: year, and then month, and then the date. So that's the format. We want, and I change the data type to date and click on the not null checkbox. And then actually we completed our main table, because the grade, the village, and the transportation method are the attributes we are not going to create by ourselves. That's because you can see in the tables under these three tables, which are under the main table, they have connections with this main table, and you can see they are the attributes of this main table. Grade, here's the grade table which corresponds with the attribute, and village and the transportation method. We just need to assign the ID. You can see the only the ID are assigned in the main table of the grade, village and the transport tables. So in this case we have to assign the relationship as a foreign key. When we are assigning a foreign key, the ID, the attributes are automatically attributes will be automatically added to the table. So that means we completed our student table here. The other three attributes will be assigned after we create the other three tables and assign the relationship. Okay, let's create the next table, which is the grade table. Here I rename the table to grade, and then here's the column name. First one is ID, and it'll going to store int values, that means integers, and I'm going to auto increment this one too. And you can see it automatically defined this attribute as the primary key, and the not null checkbox is checked too. Okay, let's create the next and the last attribute of this table, grade. That will store the name of the grade, or the the grade will store in the actual grade will store in this attribute. Okay, here the bar is okay. Let me go to the question. You can see only the numbers are, only the integer values are stored in this attribute too. We don't need to define the data type as varchar, so I'm going to change it to int. That will do for now. And here we completed our grade table. Okay, and here's the next table, which is the village. Okay, in the village table there are two attributes as the grade table, ID. The method is going to be same, so I don't repeat myself. And here's the last attribute, village. Okay, in the village attribute, you can see in the table there's word inside that attribute, so we have to change the data type to varchar and define a character length. I'm going to define the character length as 20 or 25. That will be enough to store our names of the village. Okay, we completed the village table, and here's the last table we are going to create in this question. It's the transport table. Okay, here's the transport table, and in this table here's the first attribute, ID. It is also going to be auto incremented, and then here's the last attribute, transportation method. We usually don't put spaces between, or we don't separate the names of the attribute names, table names and database names in database management systems. Otherwise that will confuse the system. So I'm going to separate these two words by using an underscore. using an underscore transportation method. Okay, here we completed our 4 tables. Let's now we have to define the relationship between these tables. When we are defining relationships, you can see only the student table has the relationship with other 3 tables. These tables, like only these 3 tables don't have relationship with each other. They everyone has a relationship with the student table. That's why I told you that's the main table. So let's define the relationship, but before that, you can see here's the grade table. uh, Let me open the question. You can see the grade table in this main table. We can for an example, you can I can let's get there can be students who's in grade 6. Okay, if there's students who's in grade 6, there's not going to be only one student in grade 6 in this entire school. There can be many students, like 5 or 10 students who has the same grade or who's in the same class and recorded in the main table called student. So the student table can store the same grade in the records, but those every record will be connected to should be connected to this record in the grade table. Only there's only one record called grade 6, and that means there's a many connection, and the many connection to the student, and one connection to the grade table. Or we can say there's a many relationship to the student table and one relationship to the grade table. So when we defining that relationship, we can I'm going to use non-identifying relationship. I will explain this non-identifying and identifying relationship, what are the difference, and what kind of what are the times we are using these 2 different kind of relationships. I'll explain that in a future video. But for now, I'm using non-identifying one-to-many relationship. We are defining the student table as the many. Sorry. Let me delete this one. We are defining the student table as the table which have a many relationship, and the grade table which have the have one relationship. So I'm going to click on the non-identifying relationship, and first you have to click on the table which have a many relationship with the other table. So I'm going to click on the student table and then click on the grade table. You can see the connection is made, and here's the grade ID is inside the or inserted into the student table as attribute. That means the grade ID is foreign to this student table or the main table. Okay, here we define one relationship. Let's define other relationship with the tables. Here you can see the village table. Village table is going to be the same as the grade table. There can be students in the student table which have the same same village or who live in a same village. So there can be many students in the student table, and there's only one village. There's only one record will be stored according to that village in the village table. So I'm going to define that as a one-to-many relationship. I'm going to click on the student table and then village table. Okay, here we define the next attribute. You can see the village ID was foreign to the student table, and here's the last one, transport table. It's going to be the same. I described that one. I explained that one before. When we are creating the database, there can be many students who have the same who has the same transport method. So many to the student table and one to the transport table. Okay, here we completed our ER diagram and defined our relationships. You can see there are now 6 attributes in the student table or the main table. Now we can create our database. The database is not created yet. We have to create this one. In order to do that, we have to use there are 2 functions called forward engineer and synchronize model. I'm going to explain these 2 methods in this video because that will going to be helpful. Here we can click on the database, and then you can see the forward engineer method or the option and the synchronize model. If you create a new database and create a new ER diagram, you have to use the forward engineering method. That means there can't be any database which created earlier with the same database name. If you are creating a new database, you have to use the forward engineering method that will create the database and put the tables inside that database. But if you have a database, if you already have a database and do some changes to the ER diagram, you can't use forward engineering method because it will delete the existing database and reset the database with the current changes. So if you have a database with the with some data and you did some changes to the ER diagram, when you are applying those changes, you have to use synchronize model that will add the changes you done to the ER diagram or the tables without affecting to the data. So I'm going to use forward engineering method because we are creating this database freshly, and here you have to insert the connection or define the connection to our database. You have to enter host name and the port and the username and the password. Here you can see my data is already here, so I don't have to do anything in this dialog box. I'm going to click on the next button. Here you don't have to do anything in this window too, so click on the next button. I have to enter the password here. You can see the dialog box. I'm going to enter my password here. Okay, here I entered my password and I'm going to check the save password in vault option. That will store my password in a secure vault, and next time I'm going to create a table, it will not going to ask to enter my data password again, it will be filled automatically with the password which is in the vault. Okay, I'm going to click on the OK button, then click on the next button. Here you can see the query that's going that which is going to execute and create our table. This is these queries are called DDL, and there are two types of queries or commands in database management systems called DDL and DML. I'm going to explain. I will explain those two types of queries or commands in a previous video. For now, I'm going to click on the next button, and here you can see our forward engineering process is complete. You have to wait until all the checkboxes are checked. Here you can see forward engineering finished successfully. Now we can close the dialog box. That means we created our database successfully. Let's go to we can see the database using the Workbench too, but I'm going to use another third-party software I used in my previous videos called HeidiSQL browser. HeidiSQL. Here you can see my HeidiSQL browser. I'm going to refresh the connection to my table. Here you can see here's the database we created, capital level school, and here are the tables inside that database. Okay, here you can see the primary keys and the foreign keys we defined in the ER diagram. They are all inside this database, and now we have to enter the data graphically. When you are storing data graphically or inserting data with a insert query, you have to keep this in mind because this one is very important. If there's any foreign keys in a table, you have to enter the details or enter the data inside the data of the table before foreign that data into a separate another table. That means in the grade table, the transport table, the village table, those tables should be filled with data. If you defining records, or if you creating records inside this student table, because the grade table, transport table, and the village table are foreign to this student table. So that's a very important thing. You have to keep that on mind, because otherwise that will show an error when you are inserting data into the table. And now I'm going to fast forward this clip and enter the details, and let's see what we have to do in the question after I enter the details. I entered all the details of the grade table, transport, and the village table. Now I'm going to insert the data of the student table. Now you will understand what I told you before, that you have to enter the details of the tables which are foreign to another table before inserting records of the table which have foreign keys inside of it. I'm going to insert the first record Here's the number 1, and here's the name Saman Kumara. Okay, here's the birthday 2005, 3rd 6 12 of the March. Okay, here you can see we cannot enter or we cannot type details into the foreign keys. Here grade ID is a foreign key. We cannot type anything in this attribute. We have to select in the attribute. That's because it's foreign from another table called grade, and there should be values inside that grade table to be shown in the grade ID when we are entering records to the student table. That's why I told you before, you have to enter details to the grade, transport and village table before you are inserting the details of the student table. Okay, here I'm going to define it, his grade, his child's grade 6, and here's the village. You can see there are village names. That's because we entered those names into the village table before. And he's from Padaviya, and here's the transportation method. He is using the bus. Okay, here we entered the first record, and I'm going to fast forward this next clip and enter those details. Okay, I entered all the details of our tables. You can see all the details are filled in the tables, and he completed one part of the question. And let's see the other part. After you created the database, the principal wanted to check your database for bugs. He has given you some scenarios. Read them carefully and write queries to get results. Okay, in this part we have to write some queries and get the correct results according to the scenario. Okay, here's the first one. Select all students who study in grade 6. Use join queries. Okay, in this part we have to find the details of the student who's studying in grade 6. And you can see the question specifically told us to use join queries. That means there are two types of queries in database based systems. They use when we are creating select queries. In this case we have to use a select query because select is the query we are going to use for we are using to search data in our tables. When we are defining select queries, there are two types of queries: select queries, join queries and subqueries. Those two queries are used to join. The join query is used to join tables, and the subqueries are using to actually in the subqueries we use one to many separate queries or separate select queries and insert the result of the of a query into another query and then get an answer from that. That's the simple definition or simple explanation to a subquery and a join query. Let's see what we have to do in this question. I'm going to use join queries and also the subqueries, so that will clear your mind. And let's create this first one with a join query. Let's go to our HeidiSQL browser, and here's the query tab. This is the place we are going to create queries and execute them. Here I'm creating the select query. You can see, let me go to the question again. In this main table, in the grade table, there is no record belongs to the or defines the grade of the student. This is only the ID of the grade table, which foreign to the student table. By the ID, we have to find the grade. By using the ID, we have to find the grade of the student. So that means we have to connect these two tables. We cannot use a single query to search the data in the student table. We have to connect or join these two tables and then find the students who study in grade 6. So let's go to our HeidiSQL browser. Here I am creating the select query. When we are creating select query, we have to use the keyword select first, then select. I need all the details, so I'm using the mark, this asterisk mark. This is the asterisk mark. When we use this mark in a query, in a select query, that means all the details of the table we are calling will be shown in the result. So I need all the details of the student, so I'm using asterisk marks, select asterisk from. This is the place where we are defining the table we want data, and here's the first table. I need student. It's better you define the database name before the table name. So I'm defining the database name now. Let me clear this table name. Here's the database name, capital level school dot, or the full stop. Here's the table name, student. We need details in the student table, and in the let me run this query now. I'll complete this question by breaking the whole question into parts. Here's the first part. I'm selecting all the details of the student table. Let's execute this query. You can see all the details of the students are shown here. Okay, here we need the details of the grade table too. So that means we have to join that table into this student table. For that, we are using the keyword join. We can use, there are many joins like inner join, left join, full join, right join, like that. There's also a join called self join. I'm going to use that one. You just need to enter the keyword join, and then you have to mention the other table you are joining to the student table. Okay, here's the first we have to define the database name. It is not necessary, but that's a good practice if you insert or mention the database name in the query. Okay, here's the database name, capital school dot, is the table name, grade. Okay, and here we have to define which part of the or which attribute is equal to the other attribute of the next table. Uh, for an example, in the grade table, the grade ID is equal to the grade ID attribute in the details in the grade ID attribute of the student table. So that means when we are defining that one, you can here how we do that. I'm going to define the first attribute name. Uh, Before that, you have to define the table. Here's the first table, student, and the attribute inside that table is grade ID equal this grade ID equal to the attribute in the grade table, and it's equal to the ID of the grade table. And here we completed that part, and let's execute this one. You can see the details are updated, and here are the details of the grade table. You can see both student table and the details of the student table and the grade table are shown in the result with the corresponding order. And here we joined our table. Okay, now we can define a condition. We don't need every student of the school. We need only the details of the student who studying in grade 6. So I'm going to define the condition. For that we need the keyword where. Okay, here we are defining the value we are seeking for. We need the details equal to the values in the table. Here's the first table. We need values equal to the value inside grade table dot ID equal, here's the value 6. We need details of the student who's in grade 6. So let's execute this one. You can see only the ID should be, let me see what's the ID is grade 6 is of the grade 6 ID 1. So we need the details of the student whose grade ID equal 1. Okay, here you can see the grade is 6, and here are the students. There are 3 records of the student who's studying in grade 6. You can also do that by defining the grade directly, like grade equal 6. That's another method to get these details. So both of these methods are working. So we completed that part of the question. You can see the details, and here we completed this one, and let's see the second one. Here's the second part of the this question. Select birthdays of the students who come from Padavia by bus. Okay. In this case, there are 2 conditions. We have to find students who come from Padavia, and also they should use the transportation method the bus as the transportation method. Okay, in this case we have to write another select query. Let's go to our HeidiSQL browser. For this one I'm going to use subqueries, because I think that will explain what the difference between join queries and subqueries. I explained that before. Let's do that in this question. For real practice, I'm going to write the first one. We have to I will break this down to separate parts, and let's find out, and at the end let's get our answer. As the first part, let's find all the student details in the student table. Okay, you know what we have to do. We have to select all the students in the student table. Here I'm writing the select query. Here's the keyword select. Select. I need all the details for now. Asterisks. Here's the asterisk mark. From here I'm defining the database name, capital level school, and here's the table we want, student. Okay, here we find our details. You can see all the details are in the result, and here I need only the birthdays of the student. You can replace these asterisk marks to a specific attribute name, so the result only show that attribute and not all the details of all the attributes in the table. You can ask for only one attribute of you can define many attributes that you want from the in the result. Okay, here I need only the birthday. Let's execute this query. You can see only the birthdays are here, and this in this result there are records belong to all the students in capital level school, so I don't need that. So I'm going to define a condition. In this part you cannot use a single query to get our answer. We cannot search for students who's come from Padaviya, and also who uses bus as the transportation method. If you use a join query, you can define that condition by using AND, the keyword AND, but in this case we don't use join queries. We use subqueries. So in the subqueries we have to use separate, or we have to write separate search queries and feed the data from those queries into the main query. We are searching the data. We used to search data. Okay, here's the main query. We need birthdays from the students who's in the capital level school, and then we need here I'm defining the condition. We need let's find the students from who's come from Padaviya first. So we need here you can see in the student table only the village ID is shown here, so we need ID of the Padaviya village. Here's the village table, and ID is Padaviya. So in this case I need ID. Here I'm defining the attribute name. Let me copy that one. Here's the village ID, and then I'm going to paste that one. We need village ID equal to the ID of Padaviya in village table. So we have to write another select query to the village table to find the ID of the village called Padaviya. In here we can use equal or, and also we can use in. Usually we use the keyword in when there's more than one results and we need to sort every we need to sort every result and feed them into the main query. In this case we only have one query, we only have one ID, so I'm going to use equal. I will use in method or in keyword in a future video. Village ID equal to, here I am writing the next select query by using brackets. You have to use brackets to separate the queries. So when the query in this bracket will execute, and then the answer will feed into the main query. So let's define that one. Select, we have to write a select query to the village table. Select, I need only the ID. We don't need every attribute in the village table. We only need the ID. Select ID. From here I am defining the, or I'm mentioning the database name and the table name. Capital level school dot. I need details in the village table. Now we have to. We don't need every ID in the village table. We only need the ID of Padaviya college. So we have to define our condition. We need data. We need ID of the village called. Here's the village name. Let me copy that name. Village. Okay. Where village equal, here's the value we are looking for, Padaviya. Let me copy that name to Padaviya. Let's execute this one and let's see the data is correct or not. You can see only 3 records are shown in the result. Let me change this one to asterisk mark to get all the details. That will help you to understand the result. You can see there's 3 students who's come from Padaviya. You can see the village ID is equal to 1. And let's go to the village table and see. You can see the ID of the village called Padaviya is 1. That means here are the 3 students who come from Padaviya. Okay, here I'm going to define or write my next condition. We need details of the students who come from Padaviya and also who use bus as the transportation method. So let's define that one. I have to define an AND operator, because we can use OR operator or AND operator. In this case we have to use an AND operator, because we have to check both conditions are true. The student, the village ID of the student should equal to 1, and also he should use bus as the transportation method. So I'm using the operator AND, and here's the other query. We need you can see in the student table we have to find the transport ID which is equal to the transport ID of the transport table, and it should equal to 1. Okay, here I am defining the attribute in the student table, transport ID. Let me copy that one. Okay, it's better you put this in double gravation marks or 2 gravation marks and equal to, here the result, there's only one or single result, so we don't need to use the keyword in. We can use equal to. Here's my next query. I'm separating that query by using two brackets, and here's the select query to the transport table. Select, we don't need all the details, we only need the ID. So here's the attribute we are looking for, ID from, here's the database name, HeidiSQL School. Here's the table name, transport, and here's the condition where let me go to the transport table where we need transportation method. Okay, transportation method. Let me put this in another set of gravation marks, and transportation method equal to bus. Okay, here we complete our complete query. Let's execute this one and see the data is here or not. Okay, you can see the data is here. Village ID is equal to 1 and transport ID is equal to 1, and we only need details of the, we only need birthdays of the students. So I am changing the asterisk marks to birthday. Okay, here you can see only the birthdays are shown here. So we completed our second part of the question. Okay, let's go to the question and see the last one. Is the last part of the question. Select names of the students who study at grade 9 and come from Mihintale on foot. Okay, we have to use in here we have to join every query, every tables inside our database. We have to join the grade and the village. Here the name of a village, and here's the transportation method. He should come from foot. He should come by foot. Okay. So in this part I like to use another subquery. Let's go to the HeidiSQL browser. We need names, only the names of the students. So here's the previous query. Let me clear this one. Let's create a new one. Select for now I'm using the asterisk marks. Select asterisk from, here's the database name, Padaviya, HeidiSQL Lab. Here's the table name. We need detail. Here's the main table, student. Here the table which holds the names of the students. So students. Let's execute this one and see if that's okay. Okay, the query is fine, and here's the condition where, here's the first subquery I'm going to use, but before that we have to define what is the attribute in the student table we are comparing to the other table. So here's the attribute in the we let me go to the student table. Is the student table. We are searching for the attribute called grade ID. Okay, let me copy this name, grade ID, and this also there will be only one result, so we don't have to use in the keyword in. Let me go to the question. Here we are looking for students who study in grade 9. Okay, grade equal. Here we need the we need to put the grade ID of the grade called grade 9 of the grade 9. So I'm going to we in this case we can put the answer. We can put the ID by ourselves, but in the question you can see they only give the grade name, so we can use the grade 9 to the query. We don't usually we don't put the ID by ourselves, so we have to use that subquery. Okay, here I separate the query, and here's the other select query to the grade table. Select, we need IDs, so ID from, here's the database, capital level school dot here's the table grade, where is the condition, is the attribute name, where the details we are looking for are stored. We are looking for the data in the, let me go to the grade table, details in grade attribute, the attribute called grade. Okay, grade equal to, we are looking for the student who study in grade 9. Okay, you can see the ID of grade 9 is 4. So let's see our ID if the result will show the student whose grade ID equal to 4. Okay, you can see the grade ID is equal to 4, and only 3 children are studying in grade 4, grade 9. Okay, here we complete our first part, and let's separate this one with let's define our next condition by using the keyword n. We have to use n to n operator, because every in this case we have to write 3 queries, so the details of the every query should be true. So we cannot use o attribute, o operator. We have to use n operator. So here's the second query. Now we are looking for the student who's come from Mihintali. So I'm going to connect the village table to this query, but before that we have to define the attribute in the for the foreign key in the main table, the student table, village ID. So village ID in the student table should equal to, here's the select query to the village table. Select, we need IDs, ID from, here's the database name, capital level school, and here's the table village, where, and village equal to Mihintale. Let me go to the village table and see what is the ID of the village called Mihintale. You can see it's 4. Okay. I copy the name to this query Mihintale, and let's see whether the students or whether the village ID of the students are equal to 4 or not. Okay, you can see the village ID is equal to 4 and also the grade ID is equal to 4. That means they are in grade 9 and come from Mihintale. And let's define our next and the last query, also the last condition. I'm using the keyword and here's the attribute in the student table. Let me go to the student table. Transport ID. We need the transport ID. Sorry. Let me copy that one. Student table transport ID. I'm copying these names because if I do any mistakes when typing the name by myself, if there's any mistake, the query or the operation will show an error when we execute this query. So transport ID should equal to, here's the last select query, select, we need IDs, so ID from, here's the database name, Capiti Gollever, and here's the transport table where, and here's the condition to the transport table where is the attribute name transportation method. Let me go to the transport table and copy the name transportation method. Okay, transportation method should equal to foot. You can see the ID is equal to ID is 2. So we need students who come by foot. Okay, let's execute this one. You can see the date records are same. The transport ID is equal to 2. So here are the 2 records which belongs to or which have this actually which respond to these 4 queries. So we completed the third one and the last one of the question, and we complete the whole question number 10. So I'm going to stop this video now, and let's see you in a next video, and thank you very much for watching this long video.